Hello everybody, I'm Jenny Caudillo.
I'm Sarah Dahel.
And I'm Youlen Ghazalian, and for our senior project, we worked on zero waste campus dining.
Today in our presentation, we'll be going over the introduction, the background, and then the DMAIC process in which we went through in order to achieve our project goals.
Our technical advisor is Professor Dr. Tally Freed, who approached us with this project. We had 3 supporting teams for this project, the first consisting of Kyle, Gage, and Raphael, who supported the project through their process improvement class. They conducted time studies on the campus dining dishwasher. The second team consisted of Austin and Frederick, who, through their Advanced Operations Research course, worked on calculating the optimal number of return bins and their ideal locations around campus. The third team consisted of Jonathan and Isaac, who through their Advanced Electronic Manufacturing course worked on designing and creating the return bin for the reusable containers. Our key stakeholders are Greg Gio, Operations Manager for Cal Poly Campus Dining, and Eric VM, Energy and Sustainability Analysis for Facility Services.
For the past couple years, Cal Poly has been moving towards being a more sustainable campus. Eric VM brought to our attention the Aussie system used at University of California, Merced, which utilizes barcodes for takeout dining containers. The Aussie system is offered through a vendor, while Campus Dining wants an in-house solution in order to save cost and gain the ability to make changes as necessary. The goal is to have Cal Poly integrate a similar system that will allow Campus Dining to track the containers and provide feedback and incentives to the customers.
The problem that was brought to our attention was that Campus Dining has a goal of becoming a zero-waste entity for the Cal Poly community, but their current carryout containers produce waste. The specifications proposed by Cal Poly Campus Dining and Facility Services was to create a design that will be able to seamlessly incorporate in the current system with little or no impact to the ongoing daily operations.
Our project goal was to have the ability to track and measure the reusable containers to prevent further waste, while providing the user an accommodating environment to ensure that they'll choose the sustainable option. We based our project on the 3 following success criteria: usability, readability, and durability.
We wanted to design an experiment that could test the effects on a reusable container life and see which method would allow the container to be read afterwards. In our design, we considered 2 methods of container tracking: barcodes and RFID. Our client requested a method to track the containers going to and from the system, so both options were considered. The tags in the containers were tested under various circumstances.
Our experiment was designed using 3 objectives: usability, readability, and durability. The independent variables of this experiment were the type of tag location on the bin, and if food was within the container. The dependent variables were readability and durability. The tests conducted were direct and indirect scanners for readability, while we had a sample of 11 tagged containers which were processed through 50 wash cycles in order to test for durability. One of our stakeholders, Greg, suggested the pilot location be at Red Radish due to the commonality of current disposable containers. A simulation using the program Simio was made to measure the amount of containers going through the process in one workday at Red Radish. Based on time studies taken by our team and supporting teams, the throughput of containers for the current process is 1,106 containers daily. In addition to testing and simulation, an economic analysis was done on current material costs, new system implementation and utility costs, as well as a 10-year depreciation.
As a team, we ultimately decided to choose RFID based on the following criteria. In terms of usability, customers will be able to throw away containers in the return bin without having to wait for the scanner, and it also does not affect the current employee's workload. For readability, RFID was read 100% of the time, and barcode is only read 4.2% of the time when used an indirect scanner. For durability, RFID and barcodes were both able to withstand the wash cycle over 50 times based on a quality check. Of the 11 containers tested, we found that 10 of the containers had no water infiltration for the RFID tags, providing a durability success of 91%. The tag containers were tested again for readability after the 50 wash cycles, and all the RFID tags were read, including the tag that was exposed to water. But the barcode containers, yet again, only proved to read less than 4% of the time. Another simulation was created for the modified process. After each entity was processed at the register, they split 20% directly to be disposed at the trash, and 80% of the entities would be checked out to customers to be returned at a later time. After one workday, 730 containers would be ready to use for the next morning. while taking into account the other containers that are not yet returned and the available batch sizes to order. It was concluded to order 2,000 containers.
For the current method using disposable containers, the annual cost is approximately $50,000, which calculates to a 10-year cost of approximately $500,000. As for our proposed method, the installation cost is $120,000. Unlike the current method, we must take the utility costs from the bins and the dishwasher into consideration. The annual utility cost is calculated to be $5,500 after the consideration of asset depreciation. The 10-year cost of our proposed method is approximately $450,000. This means that after implementation, our proposed method will have a 10-year cumulative savings of $50,000. The labor was not considered in these cost comparisons due to the fact that there will be no change in the amount of labor needed with the zero waste method. These figures provide a breakdown of utility costs and divides the implementation costs. As shown in the pie chart, one of the higher costs is purchasing the 20 return bins, costing about $73,360, due to the unit cost being around $2,300. With reusable dishware implementation, we expect there to be an added cost to Cal Poly Utilities of about $5,560. It is our recommendation to move forward with the Zero Waste Initiative in replacing the current dining disposable containers with RFID tagged reusable containers. The tags will be able to withstand the current cleaning methods while providing accurate readings when returned into the designated bins. Campus dining will be able to avoid further waste by removing the need to purchase 177,000 disposable containers annually. We suggest that the implementation initially begin at Red Radish. If positive results are shown, then move forward to other campus dining locations.
We recommend that maintenance be done on the return bins every 3 months to ensure full life value. We also discussed an incentive program with Eric and Greg in which students would be charged at the end of the quarter if the containers were failed to be returned. As we will all be graduating and no longer able to oversee and control the success of this project and implementation, we hand off the project well-being to our technical advisor and key stakeholders.
We would like to thank our technical advisor, Dr. Tally Fried, who has guided us every step of the way, our key stakeholders, and our supporting teams who helped us complete our project. If you have any question, please contact any of the team members at the provided emails.